Hi crew, this is going to be a much shorter video than the last one. I realized after I hit it that turned it off that I was like, ooh, that was a long one. I'm sorry. Tried to keep him to 15 minutes, but that one didn't go so well. Lesson 5 was a little bit longer than expected. Okay, so you're at lesson 6. So I am only going to do part of this one because it's kind of intense. So I'm only going to do the first part. And then we're going to save the rest for in class so that I make sure that I have some quality time with you guys, okay? So for the group A, that'll be the Monday. And for group B, it will be, well, actually group B, I think I end up doing this whole in class because we got that Veterans Day. It kind of messes up the order of how we're doing things, but we'll see. I might change that a little bit. We'll see. Group A for sure. So let's look. So solving higher degree polynomials algebraically. So take a minute and this is not a question problem. Find all the solutions to that. So you know how to do that. Take a minute and factor that. Remember that method? Take a minute, put me on pause, and do it. Okay, so hopefully you are you unpaused me and you got the same thing as me. So what we're going to talk about today is called the factor theorem. So let's say if C, let's C could be 1, -1, or -3 for this example, for example. If C is a root of a polynomial, then X minus C is the factor. And you already know that. We just kind of formalize it for you right now. We've been doing it because when you wrote equations, basically, I had to give you the roots and I had to go backwards. Same theory. I don't know actually why I put parentheses around here. Let's change that. So that is what we're referring to as the factor theorem. And the same piece, if x minus c is a factor, so if I give it to you as a factor, then you can say that you know that c is the root. So you should be able to go from the root to the factor and the factor to the root. That's really all we're doing with the factor theorem, is we're formalizing it. What if you cannot factor using the grouping method? Is there another way to find the factor? So if I look at this problem here and I go 4x cubed minus 8x squared minus 11x minus 3, and I think, okay, there's 4 terms, so I'm going to try the grouping method. I'm going to try it because you really should try it. And I got 4x squared is what I factor out. And I look at this and clearly for that negative 11x minus 3, I can't factor that to match that x minus 2 because, oh dear, that did erase. Oops. So I clearly can't, it doesn't work. So I am not going to be able to do any factoring here. So we could actually use our calculators. It's legitimate to do that. So what I mean by that is I would plug this, okay, these are from earlier. Like when I mean earlier, I mean like 10 minutes ago. For you, it was yesterday. If you watched them each day separately, there we go. I'm going to put this in. I'm going to put this into my y1. I'm going to be able to see it. 5x minus 3, 10x minus 3. Okay, I'm going to put this into my graphing calculator, and I'm actually going to use that that factor theorem, right? I'm going to use that thought of, okay, can I see roots? Remember, I had said not all graphs you're going to be able to see it on, so we're going to try it. I'm going to actually try and see if we can find a root here. Now, in this case, it turns out that that looks pretty clear, that I see when x is 3, it crosses the x-axis. But let's check on the table too. So when x is 3, it should say that the y value is 0. So I know right now that by using the calculator, so is there another way to factor? We could say yes. Let me go through all the steps here. So I said yes, I plug into y1 calc and find a root. Okay. And in this case, my root is 3, right? That's my root. So my factor is x minus 3 because I'm using that factor theorem. And what I'm going to do is I'm going to divide the function by x minus 3. So I'm going to come over here and I'm going to break it apart. That's what we're trying to do. That's what factoring does, right? It breaks apart the problem. Okay? And I'm going to do that by long division. Okay? Remember that? The good old days of a unit ago where I taught you long division? Okay, let's go through this. You're going to take the first term. You're going to take the 4x cubed and the x. And you're going to say, okay, what would I multiply by x to get 4x cubed? And I would say 4x squared. So I'm going to put it up here. And remember, you have to multiply it by both of these. So the 4x squared times x should give me the 4x cubed. 4x squared times negative 3 would give me negative 12x squared. I put a minus in the front. If you remember correctly, I said you got to distribute like that, remember? That's all I need you to distribute. And then you combine, so those cancel out. And then I got negative 8x squared plus 12x is 4x squared. I bring the negative 11x down, and I do it all again. So I could see, all right, what multiplies, what do I plug in here? What do I multiply x by to get 4x squared? And then I see 4x, so I distribute that. 4x squared, 4x times negative 3 is negative 12x. Stick a minus in the front. I distribute that. That cancels out. I got negative 11x plus 12, or 12 minus 11 is x minus 3. And it should, now remember, we determined already that it was a root. So you have to have a remainder of 0. If you don't have a remainder of 0, and you clearly saw that x equals 3 was a root, you did your line division wrong. Okay? All right, so what do I multiply by x in order to get x? I would say plus 1, and multiply both x minus 3 by x, or by 1. And that clearly should make it so that it cancels out, and it does. Let me erase this part so you won't see. So my point is okay, I can't factor, right, the original problem. So what I have to do is I have to get creative and I have to try and find a root on your calculator and then break that function down. Okay, so I'm going to divide the function by x minus 3 to break up the polynomial. And then 4, I want you to factor remaining polynomial. Okay, so the remaining polynomial is this part right here. Okay, so did I give myself enough room? That's really the question. Okay, let's bring this down here. And we're going to say 4x squared plus 4x plus 1. And I'm looking because I don't remember how I did, if I did this one a different way, but it is factorable. So I gotta do the grouping method. Remember I said factoring is not going away. So 4 times 1, I take the first term and the last term is 4. Middle term is 4. What multiplies before that adds before, and I got a 2. Those become my middle terms. And I group, and I take out a 2x, which gives me a 2x plus 1. And I take a plus 1 out of here, or just put a positive out there. Put 1. Okay, so now this is my final answer. I've got 2x plus 1 and 2x plus 1. Now, it said it wanted me to factor this, so don't forget, you took out an x minus 3 before, remember? Like that was an x minus 3 originally, and then I got a 2x plus 1 squared because I've got 2 of them. And there she be. So why did I do all that? Because I have to factor. It's not easily factorable. Sometimes you can see what they call a potential root, right, in the graph just by putting that function on it, or that polynomial as a function in y1, and then it helps me break it apart. Okay, let's try B. Let's do one more. Oh, and by the way, I know the questions you're going to ask me, my friends. Could I have done synthetic division instead of line division? Sure. I think that it's good. This is a good opportunity for us to practice line division, and I'm pretty darn sure. Yes, I am. I'm sure that for number 2 on the next page, I gave you an opportunity. I did synthetic on that one, so I'm going to tell you to do with that one. Let's do B first. Okay. So this is what I want from you. I want you to do some grouping. I'm going to have you turn the video off. Try and group this one, see if it works, and work your magic for me. Oh, wait a minute. I'm lying. Don't work your magic. It's the same one. I remember how I did this now. My bad. So B, instead of like looking at A, right, that was just an expression. 4x cubed minus 8x squared minus 11x minus 3. So for B, I actually made an equation. And I said to solve. So typically what we would do is we would factor. Well, I already factored for you down from up above. And then I would squiggle and I would solve each one. X equals 3. X equals negative 1/2 twice. And that is my solution. Negative 1/2 and 2. That's it. Okay? So that's just kind of talking about and the differences and how we can do factoring a little bit differently than you've ever experienced before, and that's using your calculator. Okay, so now it says use the graph of the function. Okay, so here I gave you the graph for you, like on the calculator already. It says use the graph of function f of x, blah blah blah, to solve. Where I took the f of x and I actually made it, I made it equal to 0. The function I made it equal to 0. Okay, so it's hard to tell, I'll be honest with you, whether or not this is on a point or not, like or on a actual integer. But I'm going to give you a clue. This one right here, right, is 1. Okay, so I know right now that x equals 1 is the root, which means x minus 1 is a factor, right? Because the factor theorem. Okay, so this is the opportunity I'm going to give you to actually do some synthetic division. I just lost my paper. So we're going to put we don't do the factor, we do the root. Remember, we put the root on the shelf like that. And then I take the first of each. I take the coefficient of each and a constant, and I put up here. There's no placeholders. Remember, you're still looking for placeholders. All right, I bring down the 4. Remember how this works? And I multiply the 4 times what's on the shelf. So 4 times 1 is 4. And then I just combine it with the negative 12, which gives me negative 8. And then I take that and multiply by 1. And then 3 minus 8 is negative 5. And then negative 5 times 1 is negative 5. And remember, I got to have a 0. Like, I got to have a 0 there because I know by looking at the picture, right, on my little calculator picture, that x equals 1. So when you go to do, because I don't know why, but kids don't relate this to this homework question. There's a homework question number 2 on here that just make sure that that's why I give you the little picture on the side, is I want you to see, I want you to look for one of the roots. And if you have trouble like reading the graph, just put it in your calculator then. But it does say that it goes to, I believe it goes to 4, so on the x-axis, so you should be able to figure it out. But you can always pop it in your calculator. Okay, so let's see. So we are down to now a 4x squared minus 8x minus 5. Oh, excuse me. I'm so sorry. I had that yawn. It just was dying to come out. I said I wasn't tired before, but I must be getting tired. Okay, so I'm going to leave that for you to do. And then we're going to meet up in class. And that is your video. I want you to factor that again, just like we did the other one. Right? Factor it again. And then remember, it's set equal to 0. And you've got to find basically all the zeros. So, and I will tell you, it is factorable. So you got to do grouping method. Okay? So what I would suggest you do is you don't have to do all the homework for this associated with this lesson. And I think I even put on the agenda that you didn't have to do it. You could wait until we finish this in class and then do the homework. But it might be helpful for you to start looking at it because I think the homework is kind of lengthy. I mean, not real lengthy, but it's, it's kind of meaty. These are meaty questions. So, all right. I will see you later. I'll see you tomorrow. No, Group A. I will see you Monday. This is Friday. Should be Friday. Shouldn't have waited until the weekend. Okay? Take care.